Okay, what we're going to do now is how to find the formula of a line. And again, you guys have been doing this in year 1 and year 2 already, so it should be pretty good for you, but we're going to go over it anyway just to make sure. Okay, so the formula of a line. We have over here a picture of a line on the right, and you can see it goes through some points. Okay, now we know always that the general formula of a line is y equals ax plus b, and remember that a is always the gradient or the rise over the run, and b is always the y-intercept. Okay, we're going to use that. So this picture over here on the right, I'll just move it down a little if I can so we can scroll a bit. Okay, so we're going to start by always writing the general formula, so y equals ax plus b. And you can see in this picture here that b, the y-intercept, is over here and it's 4. Okay, so we know straight away that we're going to have plus 4 here. Okay, then we just need to find the gradient. Okay, so we know we have ax plus 4. Now I want to introduce you to some new notation now. You're in year 3, and so we're going to start getting you used to notation that you're going to need in the upper years. So we'll do that for this one. When we look at the gradient, so gradient is equal to rise over run. Now, in order to show this in the upper years, when we look at something like the rise, we're looking at the difference between, for example, the height of this point and the height of this point. So we're looking at the difference between here and here. Now, we use Greek letters in maths a lot, and this is one of those situations where we use a Greek letter to represent something, okay? So we use the Greek letter delta, which is drawn like this, as sort of like a triangle. We'll make it a little bit, I don't know why my eraser's not working. This is called delta, okay? And delta, so this is the Greek letter delta, and delta means change, okay? So it's the change in something. So when we look at this, we are looking at what the y has changed by. So this is going to be delta y, okay, over. The run is going to be then the change in the x values. So we're looking at the difference between here and here. So there we have delta x. Okay, so when we talk about gradient, when we are coming up with the formulas, we tend to use delta y and delta x, and this will have more relevance when you're in year 4, particularly if you do Wisconsin B, also in year 5 for Wisconsin R students. But it's something that will come up a lot more in the future, and we just want you to get used to that notation. Okay, so A equals delta y over delta x, and in this case you can just count the squares. So y changed by, and you can see here that it changed by 2, okay, on the right, so it's 2, and the change in x was 1. Okay, so in this case we have y equals 2x plus 4, and if we just want to check that gradient, you can see, remember we said rise over run, so from a point, if you rise 2, which is what we said our gradient was, and run 1, then yes, you end up back on that line again. Okay, so that one's fine. All right, that's it. That's how you do it. So we'll do another example, and then we're going to do a harder one. So this will be the next example. Let's move the harder one away a little bit for the moment. Okay, so let's look at this example here. Okay, so y equals ax plus b, always start with that. We know that in this case b is going to be over here, which is 5. So y equals ax plus 5. Okay, a equals rise over run, which is delta y over delta x, and delta y. So we need to have a look here. You can see that from this point to the next one, it goes down 2. So the delta y is going to be -2, because remember this time it is a drop, it's not a rise, it's actually a drop. Okay, and the run, it went across 1. Okay, and that's it. So we can now say y equals, a was -2, so -2x plus 5. Okay, nice and easy. Now occasionally you will get a harder one, and that's what we're going to do here. So this last example here is one where we can't see the y-intercept. Alright, so we started off the same, always with the general formula. Y equals ax plus b. Alright, and normally we just go and we say, okay, this is b, we can substitute that in. In this case, we can't do that, okay, because we can't see the y-intercept. Yeah, we could extend the line and calculate it and blah, 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 but we're not going to do that because that's wasting time and it's also inaccurate, okay? We need this to be accurate. You might see that it crosses something and you might not have drawn your lines properly, so we're not going to do that, alright? Instead, we're actually going to start with a, okay? So we know that a equals rise over run, which is equal to delta y over delta x. Now, delta y, how do we find delta y? Well, what we do is we look at the y coordinate of the second point, and then we minus the y coordinate of the first point. So that means we're going to have y2 minus y1. This is the formula for gradient, divided by the change in x is the same thing, but we're looking at what x changes by. So it's going to be the second x point, so that we refer to as x2 minus x1. And these little subnotations here, okay, these little subnotations down the bottom here, this is not the number 2, it's just like a placeholder. We could have also said yb minus ya, and it would have been the same thing, okay, but we do tend to use 1 and 2. It just means first and second. It doesn't actually mean a value, okay? So in this case, y2 was 14 minus y1 was 4, divided by x2, which is 10, minus x1, which is 6. So let's simplify that. 14 minus 4 is 10, and 10 minus 6 is 4. So this is our a value, 10 over 4. We can simplify that, so divide them both by 2, and we get 5 over 2. We're going to leave it like this, okay? You guys have all been trained from primary school to always change things to a improper fraction, but we don't want it that way, to a mixed numeral, sorry, but we would prefer to have it as an improper fraction, because as you can see, it means more this way, okay? So we know that we have y equals 5 over 2x plus b. Okay, so we found our a value. How are we going to find b? Well, actually, we did this a couple of lessons ago, because we find b by substituting in one of the points that it goes, whoops, not in Dutch, that it goes through. Okay, so this goes through, and you just pick one of your 2 points. It doesn't matter which one. I tend to try and pick positive values. In this case, both of them are positive. I'm going to go for the lowest one, 6,4, because it just looks like it might be easier. Okay, higher numbers means more things when you're multiplying. All right, so in this case, we have x and y. Y was 4, so we're going to replace y with 4 equals 5 over 2 times, and then x is going to be 6 plus b. Okay, and we can just solve this. So 4 equals 5 over 2 times 6. So if you do 6 divided by 2, you get 3. And 3 times 5 is 15 plus b. Okay, we're going to minus 15 from both sides. 4 minus 15 is minus 11 is equal to b. So b equals minus 11. And then that gives us a formula of y equals 5 over 2x minus 11. And that is the formula of this beautiful line on the graph here. Okay, this is what we expect you guys to be able to do. You'll find this very useful whenever you're doing linear equations, so it's really good if you get in the habit of going through these steps, okay? It's really nice to try and practice it when you don't know the y-intercept, because those are typically the harder ones to do. Okay, good luck.